Hey there. In this video we are going to look at 5 trig identities, 3 that are called the reciprocal identities and 2 that are called the quotient identities. And we're also going to look at how you can identify and express restrictions on those identities.
Now, a trig identity, trigonometric identity, is an identity that contains one or more trig or trigonometric functions. I'm going to just write trig for short there. And for example, the first ones we're going to look at, you likely, hopefully, maybe have already seen before. They're called the reciprocal identities. And those are basically the definitions for cosecant of an angle, of a value, which is 1 over sine of that value. And the second of which is the secant of a value is always equal to 1 over the cosine of that value. And then the third one that goes with this is for cotangent. It's always equal to 1 over tangent. Those are called the reciprocal identities because those are the reciprocal trig functions. And there are 2 others here that we're going to look at. You maybe haven't seen these ones. They're called the quotient identities. Now, the quotient identities are for tangent and cotangent. So the first of these says that the tangent of an angle is always equal to the sine divided by the cosine. Now, that actually just comes from the unit circle definition of some of the trig functions. So if we think about it here, we'll just draw a really quick unit circle. So a circle of radius 1, we have some angle somewhere here, right there. Let's say that's theta there. And then we can look at the values here. So the radius is 1 because it's a unit circle, and this is the y coordinate, and this is the x coordinate. Now, I'm hoping you've seen before that in the unit circle, since for that angle, the definition of the sine ratio is y over the radius, or in other words, y over 1 in this case, or just y. So the y coordinate is the sine ratio. And similarly, the x coordinate is the cosine ratio there. And the definition of tangent, since tangent is the y coordinate divided by the x coordinate, even if you're thinking for that little reference triangle of just right angle trig, it's the opposite over the adjacent there, that the tangent is y over x. That leaves us with tangent is y, the sine ratio, divided by x, the cosine ratio. So that's where that identity comes from. And there's a similar one for cotangent. Now the one for cotangent we can generate just by looking at what we already have. We've just seen that tangent is sine over cosine, and we know that cotangent is the reciprocal of tangent. So the reciprocal of sine over cosine is cosine over sine. So that's the other quotient identity. They're called quotient identities because they're expressing one function as the quotient of 2 other functions. Now, for these 5 identities, being identities, as you've seen hopefully in a previous video of mine about identities in general, there are possibly sometimes restrictions on the variables involved in your identities, and these are no exception to that. There's restrictions on every single one of these identities, and we'll look at this one first here. You've undoubtedly seen that when you have a division statement here, if you divide by something that is equal to 0 on the bottom, that means that that expression is undefined. So this expression is undefined when the value of sine theta is 0. So the simple way to express the restriction on here is to say that sine theta can't be 0. Now you can think about the specific values of theta that are going to make that the case. If you wanted to write them as a list, the values of sine theta, if you've seen the graph of sine, then probably the simplest way to think about it is to just imagine the graph. It goes like this, it goes like that, it goes like that, and so on. This is 0, pi, 2 pi. Those are all the values where sine is 0, and it would just continue like that. So multiples of pi. If you went the other way, it's going to be negative pi over here. So the simplest way to write that is to write an expression saying it's multiples of pi, or in other words, you can write it as n times pi, where n is an integer. So there's those 2 different ways of writing the restrictions on this. This is probably the simpler way, although the more specific, probably ideal way to do it is to write an expression like that. Similarly, on the second one, there's a restriction here, but in this case, cosine's the thing that cannot be 0. So I'm going to write here, cos theta can't be 0 in that case. And we can write a similar, more specific restriction on that. But if we think about the graph of cosine, it starts up here at the top and goes down like that, and up and down and so on. Didn't make my axis long enough there, but this is where 2 pi is. This is where pi is. So this is actually pi over 2, 3 pi over 2. This value would be 5 pi over 2, and so on. It's odd multiples of pi over 2. This would be negative pi over 2. So if we're going to write an expression for this, it's going to be, you got to pick one of these as the starting point where it's 0, and then it's pi to any of these other ones. So I didn't leave myself a lot of room here, but I'll write it down here and move it up there after. More or less, it's going to be pi over 2, right? Pick one of them, and then to get to any of them, you're going to add multiples of pi. So that's a little bit more complicated expression, but that's what it is. We'll move that up there instead, like that. Maybe we'll shrink it down a bit because I'm not going to leave myself much room here like that. This third one over here we're going to leave for a minute because that's probably the most complicated one of the bunch. We're going to look down at the ones at the bottom here. So this quotient identity for tangent, again, we can look at this side. This expression is undefined when cosine is 0. So it's going to be these same restrictions there, which I can write out again. And for this cotangent quotient identity, it's going to be where sine is 0. So it's going to be the same as this one up here. Now, something to think about here. Having worked with tangent before, and if you've seen the graph of tangent, there are certain values that tangent is undefined, or on the graph you have vertical asymptotes. Those happen to be where tangent is undefined, happens to be the same values as where cosine is 0. The idea that tangent is undefined for certain values is evident in this identity because it's the values where this expression is undefined. And the same goes for this. You might not have ever seen what the graph of cotangent looks like. In a lot of ways it looks similar to the graph of tangent, but it's going to have undefined values or asymptotes where sine is equal to 0. Anyways, I said we skipped this one up here, and this is why. There's the fact that this can't be 0. This tangent value can't be 0. But there's also the fact that tangent itself has restrictions. It has values that it's undefined for. And cotangent has values that it's undefined for. So what you're going to find for this is it's actually both of these restrictions apply to this, because in any of those cases where sine or cosine is 0, one or the other of these is going to be undefined. So we're going to say that sine can't be 0 or cosine can't be 0. But this is a situation where it's probably best to put it in this more specific form. So if we're thinking about it in this more specific form, it's all the multiples of pi, right? So if we were writing a list here of these things, it's 0, pi, 2 pi, 3 pi, negative pi. But it's also all the ones in between there, like pi over 2, 3 pi over 2, 5 pi over 2, and so on, right? Negative pi over 2. So what it is, if you have both of these, the simplest way to write that restriction is to say that it's multiples of pi over 2, because every pi over 2, we have a value that it's restricted for. So in this case, it's actually n times pi over 2 that are the values of that restriction there. All right? So we have those 5 basic identities that you're going to start to use in your work with trig identities. We have the 3 reciprocal trig identities, and we have the 2 quotient identities, and then we've also started to look at restrictions for those trig identities. All right, that's it.